Welcome to Cambridge IGCSE Physics, Lesson 5.1. What are forces? Today we begin exploring one of the most fundamental concepts in physics, forces. Forces are everywhere around us, affecting everything we see and do. This lesson forms part of the core content for your Cambridge IGCSE Physics qualification. We'll discover what forces really are, how they work, and why understanding them is essential for physics. Let's begin this exciting journey into the world of forces. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, understand that forces are pushes or pulls. This means recognizing that every force involves either pushing something away or pulling something toward you. Second, know that forces can change size and shape of objects. Forces don't just move things, they can stretch, compress, bend, or deform materials. Third, recognize forces are measured in newtons. The newton is the SI, International System Unit for force, named after Sir Isaac Newton. These objectives align with Cambridge IGCSE assessment requirements, focusing on core knowledge and practical understanding. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, force, which means a push or pull acting on an object. Forces always involve interaction between objects. One object exerts a force on another. Second, push, which means a force that moves an object away from the source. When you push a door, you apply force to move it away from you. Third, pull, which means a force that moves an object toward the source. When you pull a rope, you apply force to bring it toward you. Fourth, newton, which is the SI, International System Unit for measuring force, abbreviated as capital N. Understanding these terms precisely is crucial for physics success. Let's explore our first core concept. What is a force? The fundamental principle states that forces are interactions between objects. This means forces never exist in isolation. There's always one object exerting force on another object. The definition is, a force is a push or pull that acts upon an object. Every force you can think of fits this description. Forces have three key properties. First, magnitude, which means size. Forces can be strong or weak. Second, direction. Forces always act in a specific direction. Third, measurement. Forces are measured in newtons, abbreviated as capital N. In equations, we use the symbol F to represent force. The diagram illustrates forces in action. The red arrow shows a push force moving the object away. The green arrow shows a pull force drawing the object toward the source. Now we examine what forces can do, their effects. Forces can cause three main changes. First, motion changes. Forces can start objects moving, stop moving objects, or change how objects move. This includes changing speed or direction. Second, shape changes. Forces can stretch objects longer, compress them shorter, or bend them into different shapes. Third, size changes. Forces can expand objects to make them larger or contract them to make them smaller. Let's see examples. Kicking a ball demonstrates motion change. The force from your foot changes the ball's movement. Stretching a rubber band shows shape change. Pulling forces change the band's length. The diagram illustrates these effects. The top shows a kick force causing ball motion. The bottom shows compression forces changing an object's shape by squeezing it from both sides. Let's work through our first example. The problem states, a student pushes a book across a table with a force of 5 newtons. Identify the type of force and describe its effect. We are given, the force equals 5 newtons, and the motion is pushing. We need to find the type of force and describe its effect. Step 1. Identify the force type. Since the student is pushing, this is a push force. It's also a contact force because the student touches the book. Step 2. Determine direction. The force acts away from the student toward the book. This is characteristic of push forces. Step 3. Describe the effect. The force causes the book to move across the table, demonstrating motion change. Step 4. State the measurement. The force magnitude is 5 newtons. The complete answer is push force of 5 newtons causing motion. Example 2 compares push and pull forces systematically. The problem asks us to compare these two fundamental force types. Let's analyze the differences and similarities. First, Push forces act away from their source. When you push something, you apply force to move it away from you. Second, pull forces act toward their source. When you pull something, you apply force to bring it toward you. Third, both types are measured in newtons using the same measurement system. Fourth, both can cause identical effects, motion changes, shape changes, or size changes. The key conclusion is that direction distinguishes push from pull forces. The graph shows this relationship clearly. Push forces have an away direction, while pull forces have a toward direction. Understanding this directional difference is fundamental to force analysis. Measuring forces requires understanding the proper unit and techniques. The unit for force is the Newton, abbreviated as capital N. This unit is named after Sir Isaac Newton, the famous physicist who developed laws of motion. The Newton is an SI, International System Base Unit, making it the standard worldwide for force measurement. When writing the symbol, always use a capital N. For measurement tools, we use spring balances that measure force directly by stretching a calibrated spring. Newton meters are specifically calibrated in Newton units for accurate readings. When recording results, always include units with every measurement. Never write just numbers. Record measurements to appropriate significant figures based on instrument precision. For example, if your Newton meter reads to the nearest tenth, record forces like 2.5 newtons, not just 2.5. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, what is a force? Give 2 examples. This tests your understanding of the fundamental definition and ability to identify real-world examples. Question 2 is intermediate. It states, a spring is stretched by 3 Newton force. Describe the force type and effect. This requires you to apply concepts about force types and their effects on objects. Question 3 is advanced. The question is, compare the effects of 2 Newton push versus 2 Newton pull on the same object. This tests your analytical skills in comparing force directions and their consequences. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In engineering, bridge design must consider force loads and structural strength. Engineers calculate the forces from traffic, wind, and the bridge's own weight to ensure safe construction. Understanding push and pull forces helps design supports and cables. In sports, athletes constantly apply forces for movement, jumping, and throwing. A basketball player pushes against the ground to jump, pulls their arm back, then pushes the ball forward to shoot. In medicine, understanding muscle forces helps treat injuries. Doctors analyze how muscles pull on bones and joints to diagnose problems and design treatments. These applications show why physics matters. Career-wise, physics knowledge leads to many professions. Engineering designs solutions, medicine uses physics for diagnosis and treatment, research advances knowledge, and the technology sector needs physics for innovation. Let's review the solutions. For question 1, the answer is, a force is a push or pull acting on an object. Good examples include kicking a ball, which is a push force, or opening a door, which is usually a pull force. This demonstrates understanding of the basic definition. For question 2, we identify this as a pull force of 3 newtons. The effect is that the spring stretches, showing shape change. This demonstrates understanding of force types and effects. For question 3, both forces have the same magnitude of 2 newtons but opposite directions. The push moves the object away from the force source, while the pull moves it toward the source. This shows analytical thinking about force direction. Now, exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method. Second, include units in every step. Third, check if answers are reasonable. Fourth, read questions carefully and identify command words like describe, explain, or calculate. Let's summarize today's lesson. The key points to remember are: first, the definition. Forces are pushes or pulls acting on objects. This fundamental concept underlies all force analysis. Forces always involve interaction between objects, with one exerting force on another. Second, effects. Forces change motion, shape, or size of objects. Forces can start or stop movement, stretch or compress materials, or expand or contract objects. Understanding these effects helps predict what happens when forces act. Third, measurement. Forces are measured in newtons, abbreviated as capital N. This SI unit provides the standard for quantifying force magnitude worldwide. For further study, review your notes regularly and rewrite definitions in your own words. Practice identifying forces in daily life. Every push and pull you encounter. The next lesson covers types of forces, which builds on today's foundation by classifying different categories of forces. Ensure you understand today's basic concepts before moving forward.